For nearly 2 decades, the United States Pentagon chased the absolute holy grail of modern kinetic warfare. They poured more than $500 million into a project that promised to completely rewrite the physical limitations of naval and aerospace combat. They wanted a gun that didn't rely on the explosive expansion of chemical propellants. They wanted an electromagnetic railgun. They wanted the ability to hurl a piece of metal at Mach 7, turning a cheap tungsten slug into a meteor that could punch a hole through a Chinese destroyer or snap a hypersonic glide vehicle in half over the Pacific Ocean. But while Washington was busy signing the death certificate for electromagnetic artillery, Tokyo was quietly working in the shadows, rewriting the laws of thermodynamics. I'm James. Welcome back to The Hidden Muster. Today, we are taking a deep forensic look at how Japan's Acquisition, Technology, and Logistics Agency, ATLA, just accomplished the impossible. We are breaking down the live-fire sea trials of the JS Asuka, analyzing the semiconductor material science that solved the barrel melt problem, and looking at why this 40mm Japanese railgun hasn't just resurrected a dead technology, it has effectively ended the era of the hypersonic missile. To understand why the Japanese breakthrough is sending shockwaves through defense ministries in Beijing and Washington right now, you have to understand the fundamental ceiling of traditional ballistics. Since the invention of gunpowder, every gun on Earth has operated on the exact same principle. You ignite a chemical propellant in a confined space, it turns into a high-pressure gas, and that expanding gas pushes a bullet down a barrel. But physics enforces a hard speed limit on expanding gas. No matter how much gunpowder you pack behind a naval shell, you can only push it so fast before the gas itself cannot physically expand any faster. That limit is roughly Mach 3. If you want to shoot down a modern 5th-generation fighter jet or a hypersonic missile traveling at Mach 5, a conventional gun simply cannot get the bullet there in time. The target has already moved miles away by the time the shell crosses the airspace. The electromagnetic railgun bypasses the limitations of gas dynamics entirely. It uses something called the Lorentz force. You have 2 parallel metal rails, you dump a catastrophic amount of electrical energy, we are talking millions of amps, down one rail, across a conductive armature holding the projectile, and back up the other rail. This creates an electromagnetic field so violently powerful that it physically forces the armature forward. There is no explosive, there is no gas, there is only raw electrical violence. The Japanese prototype, currently mounted on the 6,200-ton experimental vessel JS Asuka, utilizes a 5 megajoule power system. To put that in perspective, 1 megajoule is roughly the kinetic energy of a 1-ton vehicle moving at 100 miles per hour. Japan's ATLA is dumping 5 times that amount of energy into a single 320-gram, 16-centimeter-long steel and composite dart in a fraction of a millisecond. The resulting muzzle velocity is a staggering 2,300 meters per second. That is Mach 6.5. At those extreme velocities, the weapon does not need an explosive warhead. When a tungsten slug hits a target ship or an incoming aircraft at Mach 6.5, the sheer kinetic energy of the impact vaporizes the target's armor on a molecular level. It behaves less like a bullet and more like a meteorite strike. So, if the physics are so brutally effective, why did the United States Navy fail? The answer is a phenomenon known as arc erosion. When you push millions of amps of electricity through metal rails, the resistance generates heat. Not just warm heat, we are talking about plasma-level temperatures that rival the surface of the sun. In the U.S. Navy tests at Dahlgren, the heat was so intense that the armature would literally weld itself to the rails as it was moving. The friction would tear massive chunks of metal out of the barrel with every single shot.
The Americans realized that their multi-million-dollar weapon had a barrel life of barely a dozen rounds before it had to be completely rebuilt. In a sustained combat scenario against a swarm of incoming missiles, a gun that breaks after 10 shots is worse than useless. It is a liability. This is where Japan leveraged its greatest domestic strength, advanced material science derived from its semiconductor industry. Tokyo knew they couldn't solve the heat problem with raw copper or standard steel alloys. Japanese engineers went into the lab and developed a proprietary, highly classified composite rail material. While the exact metallurgical blend is a tightly guarded state secret, intelligence indicates it involves a self-lubricating, high-conductivity alloy with advanced ceramics. But they didn't stop at the rails. The power module itself was completely re-engineered. Instead of massive, bulky power banks that took up the entire hull of a ship, the Japanese utilized compact ceramic film capacitors and gallium oxide components. They managed to fit a 5 megajoule power system into the footprint of a standard 20-foot shipping container. The result of this material science breakthrough was absolute mechanical endurance. During testing in late 2023 and throughout 2024, ATLA proved they had shattered the American ceiling. They fired 120 consecutive hypersonic kinetic strikes back-to-back, with the barrel maintaining perfect structural integrity. Let me repeat that. 120 hypersonic kinetic strikes back-to-back, with the barrel maintaining perfect structural integrity. They didn't just solve the American problem, they mastered it.
In the summer of 2025, Japan took the safety off. They moved the prototype out of the land-based laboratories and bolted the 8-ton, 6-meter-long turret onto the forward deck of the JS Asuka. They sailed out into the Pacific Ocean to do what the United States Navy never accomplished. They fired a ship-mounted electromagnetic railgun at a real, physical target vessel at sea. Up until this point, critics argued that a railgun could only work in the perfectly controlled environment of a laboratory. They said the corrosive salt air of the ocean, the pitching and rolling of a ship's deck, and the complex integration with a vessel's radar systems would make aiming a Mach 6 projectile impossible. The Japanese Maritime Self-Defense Force silenced those critics. Using a combination of onboard electro-optical cameras and the Asuka's advanced radar suite, the crew tracked a moored target vessel miles away. They charged the ceramic capacitors, locked the firing solution, and let the Lorentz force off the leash. The ATLA footage released at their Defense Technology Symposium confirmed the brutal reality. The 320-gram darts achieved stable, perfectly flat trajectories. They didn't tumble. They didn't veer off course. They slammed into the target vessel exactly where the fire control computers predicted. They punched clean, hyperkinetic holes through the steel bulkheads. This test fundamentally shifted the balance of power in the Indo-Pacific. It proved that the weapon is no longer a science experiment. It is a functional, lethal maritime strike platform. And it arrived right when Japan needed it the most. To understand why Japan is pouring billions of yen into this specific technology, we have to look at the nightmare scenario keeping defense planners awake in Tokyo. The modern aerial battlefield has evolved faster than standard air defenses can keep up. Right now, the greatest threats to the Japanese mainland and its frontline islands are Chinese drone swarms and hypersonic glide vehicles like the DF-17. A hypersonic missile travels so fast and maneuvers so unpredictably in the upper atmosphere that traditional radar systems struggle to track it. Even if you can track it, intercepting it is a mathematical nightmare. Currently, if a hostile nation fires a hypersonic missile at a Japanese Aegis destroyer, the ship has to defend itself by launching an SM-6 interceptor missile. The SM-6 is an incredible piece of engineering. It is also a massive chemically propelled rocket that costs roughly $4 million per unit.
If China launches a saturation attack, say 50 drones and 20 hypersonic missiles at once, a single destroyer will simply run out of interceptors. The ship's magazines are only so deep. Once the vertical launch tubes are empty, the ship is defenseless. This is the strategy of asymmetric attrition. You overwhelm a multi-billion-dollar warship with a swarm of cheaper weapons until the ship can no longer fight back.
The Japanese railgun completely obliterates this strategy of attrition. It changes the economic mathematics of warfare. When you fire a railgun, you are not firing a $4 million missile packed with complex guidance computers, rocket fuel, and explosive warheads. You are firing a sculpted piece of metal. A high-end hypervelocity railgun projectile costs approximately $85,000. A simpler, unguided tungsten slug costs mere hundreds of dollars. Furthermore, a standard destroyer might carry 90 interceptor missiles. Because railgun ammunition is entirely inert, meaning it contains no explosive powder, it is incredibly small and completely safe to store. A ship equipped with a railgun could easily carry thousands of rounds in its magazine. If an enemy launches a swarm of 50 incoming drones, the Japanese railgun does not need to calculate complex interceptor paths for 50 separate $4 million missiles. It simply aims the turret and fires a sustained burst of Mach 6.5 darts. It throws up an impenetrable wall of hyperkinetic lead. The sheer velocity of the projectile means the incoming missile or jet has absolutely no time to evade. If the radar can see it, the railgun can kill it. This is the concept of the bottomless magazine. It allows a naval vessel to remain on station, actively defending a coastline or a carrier strike group for weeks at a time without needing to return to port to reload its vertical launch tubes. It makes the warship functionally immune to saturation attacks. So, what is the next step for this technology? Now that the JS Asuka has proven the weapon works in a maritime environment, ATLA is moving aggressively toward operational deployment. The primary goal between now and 2027 is extreme miniaturization. Japanese engineers are working to reduce the volume of the power system by another 50%. They're designing the railgun architecture to integrate directly into the Aegis combat system. This means the railgun won't just be fired by a guy looking at a camera, it will be slaved to the ship's supercomputers, automatically tracking, prioritizing, and destroying targets at speeds beyond human reaction times. The ultimate destination for this weapon is the 13DDX, Japan's highly classified next-generation stealth destroyer, currently in the design phase. Renderings already show the 13DDX with a specialized bow layout specifically designed to house the massive capacitor banks and the 40mm railgun turret. But Tokyo is thinking bigger than just naval applications. Because the power systems have been so successfully compacted, ATLA is actively exploring land-based platforms. Imagine heavy, multi-axle trucks parked along the Miyako Strait, each carrying a mobile railgun linked to a centralized radar network. They could create a permanent, impenetrable dome of kinetic defense over the Japanese archipelago. Any hostile aircraft or ballistic missile entering that airspace would be immediately met with a storm of Mach 6 tungsten. For 20 years, the military-industrial complex told us that the electromagnetic railgun was science fiction. They told us the materials didn't exist. They told us the heat was too extreme. The United States Navy spent a fortune proving that it couldn't be done with brute force. Japan looked at that failure, applied a decade of silent, relentless engineering, and proved that the impossible was just an engineering problem waiting to be solved. The tests aboard the JS Asuka in the summer of 2025 were not just a successful trial of a new gun, they were the opening shots of a new era in global defense.
The hypersonic missile was supposed to be the ultimate unstoppable weapon of the 21st century, but as we have seen time and time again, for every sword forged in the fires of conflict, a stronger shield is eventually built. Japan didn't just build a shield, they built a sniper rifle that fires meteorites. The economic model of modern air defense has been shattered, and the balance of power in the Pacific will never be the same. I am James Belay. This has been a forensic deep trace analysis for the hidden muster. Keep your eyes on the telemetry coming out of Yokosuka Naval Base, ignore the outdated doctrines, and remember that in this game, the nation that masters the physics always commands the battlefield. We are out.